using it to solve equations and converting it to vertex form because it's a little bit different in each method. So our first example, we've got converting to vertex form from standard form. So f of x equals x squared minus 10x minus 13. So remember, the first step in the process is cutting that middle term in half. So half of 10 is 5. And then whatever value we get once we cut it in half, we add that squared to the end. So I'm just looking at the x squared and the x term in order to complete the square. So that minus 13 isn't considered at all when I'm completing the square. In addition, I added 5 squared. That was a change to my equation. Because I'm not balancing it on the other side, I don't have a number that I'm going to be adding it to on the other side. I'm going to balance it on the same side by subtracting 5 squared. So essentially I'm adding 0 because I added 5 squared and subtracted 5 squared. So I didn't change the original equation that we started with. Everything that's grouped in parentheses factors to x minus 5 quantity squared. Remember, the sign in front of that middle term tells us the sign once we factor it into our binomial. And then negative 13 minus 25 is negative 38. So there's our equation in vertex form. And of course, we've got the negative 5 inside the parentheses. So when we pull it out, it becomes a positive 5. And then the negative 38 is outside the parentheses, so that stays a negative 38. So that's our vertex for the first equation. We'll take a look at another example. Completing the square, again, cutting that middle term in half. So this time we've got 12x. So we add 12 squared inside our parentheses. I'm grouping the first set of terms together because that's what I'm going to use when I complete the square. Again, the constant, in this case plus 145, I did not use to complete the square, so that goes outside the parentheses. And I added 12 squared, so I have to balance that by subtracting 12 squared. Factoring my set of parentheses, I've got x plus 12 quantity squared. Outside the parentheses, I've got 145 minus 144, which is plus 1. So my vertex is a negative 12, positive 1. If you have a coefficient other than 1, completing the square again is a little bit different. So when we use completing the square to solve equations, we would divide everything by the coefficient. We would divide on both sides of the equal sign. But I can't divide f of x by 2, so what I have to do instead is factor it out. So what I'm looking at, again, is just those first two terms. I don't need to factor the 2 out of the constant on the end, the 22. I just need to factor it out of my x squared term and my x term. And the minus 22 is on the end. So it's starting to look like vertex form. But the square is on the inside of the parentheses, not the outside. So I have to complete the square to finish that. So I complete the square inside. I cut that 4 in half. I had a 2 left over, so I add 2 squared. My minus 22 is on the outside. Now this time when I balance, I'm not just going to subtract a 2 squared, because what I have is the 2 squared times 2. I created a distributive problem when I factored that 2 out. So 2 squared gives me 4, times the 2 gives me 8, so I have to subtract 8 on the outside of the parentheses to balance the 8 that I added inside. Factoring the trinomial, my set of parentheses, factors to the binomial of x minus 2 quantity squared. And then outside the parentheses, the negative 22 minus 8 is negative 30. So my vertex is 2, negative 30. In my second example, same process. I'm going to factor out the 3 from just the x squared and the x term. My plus 1 is not used to complete the square, so that's just going to go outside the parentheses. Completing the square pattern inside the parentheses, I have a 1x left, so I'm going to add 1 squared. And again, I have a plus 1 times 3, or plus 1 squared. So I really need to subtract 3 outside my parentheses instead of just the 1 squared. Factor in, I get x plus 1 quantity squared. 1 minus 3 is negative 2. So my vertex is negative 1, negative 2. So that's the process of completing the square to put the standard form equation into a vertex form equation. Now we're going to take a look at an application problem. So we've got this path of a baseball modeled by the function h of t equals negative 16t squared plus 32t plus 5.5. H, this piece right here, h of t, the function h, the answer represents the height of the ball, and t is the time in seconds, how long the ball has been traveling. The ball is descending when it passes 7.5 feet above the head of a player who's 6 feet tall. So our first question that we're looking at is to the nearest hundredth of a second, how long does it take this ball to pass over the player's head? So what I notice is the height of the ball as it passes over the player's head, it was 7.5 feet above the head of the player, and the player was 6 feet tall. So the ball was a total of 13.5 feet in the air. So I'm substituting that in for h, or for the h of t piece. And our question is how long? So t is our variable. So when I see an equation like this, I'm thinking I'm going to have to complete the square because I've got the t squared and the t piece. Now this is a completing the square equation because I have a number on the other side of the equal sign. It's not just a function. So I'm going to start by subtracting that 5.5 from both sides, so that I can isolate the t squared and the 32t. Then I've got a coefficient in front of my squared, so I'm going to divide everything by negative 16. 8 over negative 16 simplifies to negative 1/2, and 32 divided by negative 16 is negative 2. Completing the square with the t squared and the t, I'm adding 1 squared. This time I can balance it on the other side of the equal sign by adding 1 squared. Combining my terms on the left-hand side, 1 minus 1/2 is 1/2. And factoring the right-hand side, I get t minus 1 quantity squared. So to solve the equation, I take the square root of both sides. Now this question said we're rounding to the nearest hundredth, but I am going to go through the process of keeping an exact answer, just so you guys can see that piece again before I use the calculator. So we've got the square root of 1/2. I'm also going to go through simplifying radicals again, just as a review. Equals t minus 1, and that's a plus or minus 1/2 when you take the square root. So now I'm going to go out to the side here. We're going to rationalize the denominator for the square root of 1/2. Anytime you've got the square root of a fraction, you can take the square root of the numerator over the square root of the denominator. Well, the square root of 1 is 1, so this is positive or negative 1 over the square root of 2. To rationalize the denominator, you multiply by the radical that's in the denominator. And of course, to keep things equal, we multiply the numerator by that as well. So this becomes positive or negative square root of 2 over 2. So looking back at this equation, I now have positive or negative square root of 2 over 2 equals t minus 1. So to solve for t, I'll add 1 to both sides. So this tells us that the ball was descending when it passed over this player. So I know that the greater of the two answers is going to be the time. So I'm going to do the 1 plus square root of 2 over 2 as opposed to the 1 minus square root of 2 over 2. And when I calculated that as a decimal, I got about 1.71, approximately 1.71 seconds. So make sure you label your answer as well. All right, and the last piece is calculating the speed of the ball. So the player is 122 feet from home plate. What's the speed? Well, speed we usually talk about as miles per hour, but the ball isn't traveling for miles and it's not traveling for hours. It's traveling in feet and it's traveling for seconds. So we're going to calculate the speed of the ball in feet per second. Well, it traveled 120 feet in about 1.71 seconds. So all we have to do is divide those two to get the speed of the ball. And I got pretty close to 70 feet per second. Alright, so when you come to class on Wednesday, we'll have an assignment on this, and we'll also be setting things up in learning teams. So I will see you then.